Hello and welcome to section 2 of chapter 5. Here we actually start to take apart the periodic table itself. And in order to understand about the periodic table, we're going to talk about the guy who first put it together. He was a Russian guy named Dmitri Mendeleev. He, in the 1860s, tried to organize all of the elements based on their properties. Now, this is like all of the things that they have in common, all of the traits or characteristics that they have in common. And that was really kind of confusing. It made sense to put all of the gases over here and all of the metals over here, but it needed to be organized more than that, and that was really hard to do. A lot of different people tried it. And then so he started by, okay, if we do it by properties and by weight, that's okay. But it was really hard, especially in the 1860s, to find the weight of a single atom. And then you had the isotopes, because isotopes made things more confusing. Because, you know, here's a chlorine that weighs this much, and here's a chlorine that weighs that much, because this one has 18 neutrons and that one has 20 neutrons. And they didn't really understand about isotopes at the time. They kind of did, but, you know, So a bunch of people tried a bunch of different ways to put the periodic table together. He also wanted to really make sure that the things that they have in common were really addressed. So he really worked hard at trying to put all of this together. And the way it ended up happening was all about their electron shells. So we started by putting all of the elements in order by their atomic number, their number of protons. And if you read from left to right across the periodic table, you will see it starts 1 and 2 across the top, and then the second row, and you can just count all the way through. And it goes higher than at 118 at this point. The rows indicate the number of electrons that are in the electron shells. And those rows are called periods. So the first, you start with a nucleus, and then the first shell, the first sphere around there that electrons are in, there can only be 2 electrons there, ever. And so you can see that the first row only has two elements in it. And then the second row has 8 elements in it. Well, the next electron shell has 8 electrons in it. So you can get 8 different elements there. The next row also has 8 because the next electron shell has 8. So the rows actually tell us exactly what their electron shells look like, which is it really helps us out. But he's also got them spaced weird, especially in the beginning. And the columns are the properties, and the columns are called groups or families. So everything in the column that's all the way on the left side, but this is this side because you're looking at me. So everything on the left side is really super reactive because it only has 1 electron in its outermost shell. And everything that's on the far right of the periodic table, their electron shells are completely full, so they don't react at all. So everything in columns has very similar properties in the way that they react. And that told people, just at first glance, told people the most information, which is why scientists all over tended to accept Mendeleev's periodic table over all of the others that were written. And then his became standard and has been ever since. So then we go into even more organization. So if you look at a periodic table, you notice that some of the squares have different colors, and the color indicates whether the element is a metal, a non-metal, or a metalloid. Metals are like gold and tin and silver and copper. Non-metals are like the hydrogen and helium and gases like that. And then you have these weird things that have some metal properties and some non-metal properties, and so they're kind of a combination of both of them, and so we call these metalloids. and they're a diagonal line in the middle. And in this particular example, they're a diagonal pink line in the middle. So you've got a whole bunch of metals out there, and that doesn't necessarily mean they're shiny and you can make a spoon out of them. They've got some different properties, and we'll go through that when we look at all of those. And then over on this side here, you've got all your nonmetals plus hydrogen, because hydrogen's a gas, so it's not a metal. And then you've got all of the metalloids in this weird diagonal line here. So here we have a periodic square, and this particular square is a square of hydrogen. Now, behind my head is the giant H for hydrogen. It's a capital H. But there are other bits of important information, and they're on every single periodic table. Now, sometimes they're in slightly different sizes and such, but the largest number, or the number that's on top, right up here, this is the atomic number. So this is the number of protons that it has, and this is the number that has to be in order in a periodic table. The symbol, this capital H that you can't see because I'm in the way, the symbol is always the biggest thing in the square. And then underneath the symbol, you always have the name spelled out for hydrogen, or whatever it is that the element is. And then the bottom number is always the mass. That's the atomic mass, and that's on the bottom. And that is the number of protons plus neutrons. Now remember that we've come farther in our ability to measure atomic mass. We have more sensitive equipment now, so this number is not exactly 1. So you always remember that you have to round off. And you need to round off accurately. So you can see here that the mass here is going to tell the number of protons plus neutrons. So in hydrogen, I have a proton number, that's 1 up here, but I've got a mass of 1 down at the bottom there, which means that it doesn't have any neutrons. But then, if you go to helium, helium has an atomic number of 2, but it's got a weight, a mass of 4. That means it's got 2 protons and it's got 2 neutrons. Okay? I need you to be able to use these squares and pull out the information you need so that we can build things. Other information that you can get from all of this. Some charts, periodic tables, will even tell you if an element is a solid, a liquid, or a gas when it's at room temperature. Often you will see mercury as different because it's a liquid at room temperature. There aren't very many liquids at room temperature. Most things are either solid or gas. So there's like 2 or 3 that like have different colored symbols, and those are always and those are the liquids. But there should be some kind of key on there somewhere to tell you what all of the different colors and symbols mean. But what I really need you to understand, there are 7 rows, and that represents the 7 spheres, the 7 electron shells of the atoms. And so the first one only has 2, and the second and the third one have 8, and then you go more. Okay, and then there's always that really long strip on the bottom. That's actually the 6th and 7th row, and that row should go in the middle. It should actually go there, but that would make the periodic table really super long, and then it would be too hard to like print posters and stuff like that. So what they did is they took that middle section that only was 2 tall and pulled it underneath and then squished the rest of it together. So I need you to understand that that part kind of sticks in there. But otherwise, yeah, there's 7 rows. More about periods. So the electron shells can only hold a specific number of electrons. So the first, please write these numbers down. The first row is always 2. The second and the third are always 8. The fourth and the fifth are 18. And that's the periodic table, is 18 wide. And then you get to the 6th and the 7th with that extra long thing, because that's 32 squares long. There's there's 32 electrons in the 6th shell, and there's another 32 electrons in the 7th shell. So you've got this huge atom with all of these electrons floating around it in this huge space, which means there's a bunch of empty space in those atoms. But it also means that the nucleus inside there is really dense, really heavy, because it's going to hold all those, I mean, like 118, 120 protons. That's just the protons. That's not also including the neutrons. So you've got the potential for a really, really heavy elements there. So here's the periodic table that's in your book. And you can see that it's got the different colors for metals, nonmetals, and metalloids. You can see that if it's black, it's solid at room temperature. If it's a white letter, it's gas at room temperature. And then you see the mercury and the bromine that are liquids at room temperature. You can also see that it tells you that going across is a period and going down is a group. Those can also be called families. And we are actually going to go through a lot of the groups so that you can get to know some of the properties that are constant through the groups. Okay? So I hope this was helpful. Take care, and I will see you next time.